Welcome to the future.
Welcome to the Muxall Open Internet of Things video blog. I am your host, Michael Crane. Well, today's topic is the BOM. Well, we're not actually going to have a video about that kind of BOM today. Today's BOM we're going to cover is the Bill of Materials BOM, which I guess can be a BOM. If you put it on your boss's desk and he screams, then I would call that a BOM, dropping a bomb. Anyway, so what is today's video going to be about? The Bill of Materials for the movement. And actually, it's this BOM is going to cover the parts required to build the movement test bed, right? And that's basically all the electronics. And I'll show you a picture of it here. Inside the BOM is the DigiKey section that covers all the electronics for the main PCB, button PCB, and also the wires and connectors. So the next thing we're going to do is we're going to update the main PCB schematic in DipTrace, and then we're going to export the DipTrace bill of materials by Reference Designator. And this isn't going to be a DipTrace tutorial, because I'm sure there's a lot of people out there using different design packages. So I'm not going to go into the nuts and bolts of how to use DipTrace. I'm sure all the electronics design packages have the ability to export a bill of materials from the schematic. The next thing we're going to go over are the remaining sections of the bill of materials. And they're the third-party components. Third-party being components that I'm not building or Muxall's not making, right? And some of the components are optional, and you'll be able to see that in the if they're zeroed out in the bill of materials. That means it's optional. I guess there's probably a lot of things that are optional in the bill of materials, but the ones that I consider optional are zeroed out. All right. Okay, so one of the things that this bill of materials doesn't include is the fancy wooden enclosure, right? And that thing has got a bill of materials of its own. We're going to cover all that in future videos, so we'll just leave that for now. There is a plastic enclosure in this bill of materials that I believe is zeroed out. We'll have to look. But for a test bed, you don't need an enclosure. In fact, if you're doing hardware development, you don't want an enclosure, because you won't be able to probe anything if it's all stuck in a box, right? So, this bill of materials does not include any labor. There's labor for building soldering the components on. There's labor for making the wires, and a labor for assembling it, right? So none of that's included in this bill of materials. Okay, so the last thing we're going to do is we're going to finish up by exporting the bill of materials, the bill of materials by RefDes that we exported from DipTrace, the main PCB schematic, and the Gerber files, and we're going to upload them to GitHub so you guys can download them and check them out. So that's about it. Let's get started. Here's the DigiKey part section, if you will, for the bill of materials, and And as you can see, it's mainly just electronic components, varistor, caps, diodes, regulars. There's the TI Burr Brown deck, and here's some connectors and that sort of thing. And it shows the unit costs of all these components. And this is if you buy small quantities. This isn't if you buy thousands of them. Some of the small resistors, you might as well buy 500 of them as same price as buying 10. So so this is what you're going to need to build the main PCB and the button PCB, right? And here are the DigiKey part numbers. For some bizarre reason, clicking on those doesn't work, but I'm going to upload this as a PDF, so none of these hyperlinks will probably work anyway after I do that. I don't know, they might, but you can just plug these numbers into DigiKey and it should pop them right up. One thing I want to mention is these are the descriptions that we're going to add as a new field in DipTrace. So, and we're going to add that so when we export the bill of materials from DipTrace by Reference Designator, we get these descriptions so we can match up the parts to the bill of materials. So when you order these parts, you're going to get them all in, and it would be nice. It makes it a lot easier if you can try matching them up by the description in the bill of materials instead of just a generic name. And you'll see that when we start looking at DipTrace. Okay, so the rest of these sections are Amazon, Adafruit, Parts Express, and we'll get down to the miscellaneous ones in a second. But these are for basically off-the-shelf components that we need for the Muxall movement. So, okay, we'll start. So we need a power supply. I don't know about that price right there. That price is probably changed, and these Benzet, or however they're pronounced, power supplies, I don't think are very good. It was pretty cheap, but I kind of like the Meanwells a little better. Unfortunately, the Meanwells are a little bit pricier. It depends on what you're doing. If you're just messing around, a cheap one might be all you need. You also might not need one that's 10 amps, and we're going to visit that in a future video. And I'll show you the reason why it's sized that way. That's very large, and to give you a kind of hint, it had to do with the audio amplifier. So we're going to take a closer look at that later. Okay, so the next one on the list here are just the push buttons, and this is this right here is the flash for the Raspberry Pi. This little OSEP IRD detector, I have only been able to find it at Hobby Central or Fry's. It would be super simple to build. The problem is when you build a custom board, this thing's only 1 inch by 1 inch square, and then you have to buy the 20 cents worth of parts or $1 worth of parts that go on it. But by the time you have it the PCB manufactured and assembled and shipped to you, those little boards get pretty expensive, and it's hard for me to justify building my own board when I can buy one for $9. But I'm sure if I bought them by the thousands, I could get them for $2 or $3 each. But that would be a different story. So okay, let's moving on. So on the Adafruit section here, We've got the Raspberry Pi, of course, and these prices vary. Actually, all these prices right here, some of them are pretty old. So, I mean, you might be able to get a Raspberry Pi 3 right now cheaper than that. I know they sell some other Pis that are, I forget what they're called, the Raspberry Pi Zero. That's, I don't know, $10 or something like that. And then the little TFT display, 5-inch color display. This is the HDMI decoder. Here's that little amp I was telling you about. That's a 20-watt Class D. And these guys right here, see if you notice they're zeroed out right here. These are external Wi-Fi antennas. They're USB Wi-Fi antennas. And that's if you're getting a real weak Wi-Fi signal from the built-in Wi-Fi that's in the Pi up here. You can plug one of these guys in there, and it'll make it better. All right, we'll go over that. And then here's some stuff from the Parts Express. This is where I get the speakers and some speaker wire, or actually use two different kinds of speakers. I use the Tang Band down here, which are my favorites, and but you can also use these Aurora Sound speakers, and you know they're a little bit cheaper, and but they sound pretty good too. Okay, and this last section here is some miscellaneous. I call it miscellaneous. So here's the main PCB I had designed from or had made or manufactured by Bay Area Circuits in San Francisco, and the button PCB. And as you can see, when you order one off, I think I ordered like 2 or 3 boards at a time. They get pretty pricey, and even at I think 100 quantity, they still wanted $33. And I know if I shopped it around and found some Chinese companies, I could probably get them, you know, down to, I don't know, $4 or $5 a board. But I just haven't had the need to order a whole bunch of boards and you know, to get the price down and also make the effort of going to a Chinese company. So, all right. You know, then the rubber feet, and this little keyboard is just a little rubber keyboard. And here's the plastic enclosure I was telling you about earlier. And I originally had this thing built at Toolless, and it's toolless.com. It was actually more than $77 because of all the setup fees. But you know, once you get all set up and you order, you know, small quantities, they wanted $77 each, which is pretty expensive. But it is what it is. So anyway, that's the bill of materials summary, and get started. Okay. Exporting a bill of materials, also called the BOM, from PCB Design software is essential for identifying the name and value of each component to order. The design software also exports the reference designator for each component. The reference designator, also called RefDes, is the key for matching components on the PCB to components in the BOM. Since DipTrace exports the BOM by RefDes, the number of line items is greatly increased because there is no consolidation of like components. Therefore, the Movement MX3 bill of materials was used to consolidate the quantities and reduce the number of line items. The description field was added to help the purchasing department identify the exact part the engineer specified. However, this consolidation created a disconnect between the Movement MX3 BOM and the dip trace BOM. There needed to be a key in both BOMs, so when the ordered parts arrive, the engineers can locate the part for each footprint on the PCB. It would seem the logical solution would be to use the RefDes as the common key. Since reference designators are easily changed in the design software, each engineer would have to be responsible for updating the reference designators in the consolidated MX3 BOM when they make changes to the RefDes in the schematics. Therefore, adding a RefDes field to the consolidated MX3 BOM would be very troublesome and error-prone. In DipTrace and other PCB design software, the components have several fields in its properties object to help the engineers identify and find different parts. It was soon discovered that none of the default fields in DipTrace would make a good common key. However, DipTrace does allow the engineer to specify custom and searchable name value fields in the component's properties object. Therefore, it was decided to use the description field in the consolidated MX3 BOM as the common key. So, a custom description field was added to each component's object in DipTrace, with the MX3 BOM description as its value. Besides eliminating the RefDes as the common key, this custom description field has the added benefit of allowing the engineers to match received ordered parts with component footprints on the PCB without having to open the consolidated MX3 BOM. Okay, I wanted to show you a couple changes I made. One is in the schematic. I went ahead and just added a title block here and the open source logo, and also did that on the PCB layout. I also put the version number in both these. They're both version 8, so we can try to keep up with it. I don't know, this versioning is liable to change, but for now let's just go with it. If you're not familiar, this is the main PCB, and it's broken up into logical function blocks. Some of the blocks have names, some of them don't. You can kind of just figure them out. They're all connected via these net connectors. And if you have any questions, you can, of course, put them in the comments, and I'll try to answer them, or someone else can. We'll go over this stuff more in future videos, so don't worry if you don't understand something. Also, there's another block in DipTrace. There's a tab down here that you can switch between the main and audio, and this one's just one big block. This is the audio section, and you can explore the audio section as well. And actually, on the PCB, the audio section is on the top here in this PCB drawing, and most of the rest of the stuff, like the power section, is down here on the bottom. All right. So now we're tasked with saving these files into GitHub, and I've been, trying to figure out the best way to do this that makes sense. So let's just go to GitHub real quick. So normally, what someone would do, or even myself, is if we want the hardware, unfortunately in GitHub you can't just download the hardware directory. But what we want to do is go to the tags and then find the most recent tag, which is v0.3.2. Okay. And then we're going to download this guy. We're going to download him as a zip file. So I'm just going to cut him and paste him here. And now let's extract him. Let's see, did that work? Yeah, that looks like it worked. Yeah. Okay, so I'm going to delete this zip file. We don't need him anymore. Yeah, so normally you would come in here and you would go to the hardware directory. Oh, how come it didn't open? Huh. Well, that's strange. Double clicking on it didn't open it. So, yeah, you go to this hardware directory, and then you would just open the schematics straight from this directory. Except we don't have any schematics uploaded, and I haven't really figured out how I want to do this. I mean, I can upload the dip trace files, but without the libraries, it's not going to display correctly. So for this video, I'm just going to save all the files off as PDFs, and then I'll export the PCB as a Gerber file, or Gerber files. Let's get started here. So I'm just going to say File, Print, and we want to create a PDF file. And we're going to put them in this guy right here. I'm going to take this name off. All right. So that looks pretty good. X out of that. Okay, let's see our Gerbers here. And I'm going to create a subdirectory here temporarily for our Gerber files. So new folder. I'm going to say PCB Gerbers. Okay. And now we want to export Gerber, and we'll just do them all. Let's see here. Documents. Oh, there it is, at the very top. Hardware, PCB Gerbers. Oop. Okay, and I think it's going to do this like one at a time, so. Okay, close that. All right, next on the list, I'm gonna save off this bill of materials and the ref desk export. Okay, I had to change some of the formatting in the Excel spreadsheet in the print preview to get it to print. And I went ahead and added a name and date to it. But yeah, that looks pretty good. I see it did the hyperlinks. Well, I guess they got exported as well, so maybe they'll work for you. Anyway, that's good. Let's go ahead and do this other one real quick. Let's see. All right. Well, it looks pretty good. Okay, I'm going to start uploading some of these to GitHub. Let's see. Okay, so this is pretty sad. So I'm new at GitHub as well. And I already forgot how to use it. So I think we need a new pull request. So I'm going to just, let's just try the files and see what happens. So we want to upload files. So I'm going to choose my files. Okay. And I don't think I can, yeah, see, I think I'll have to zip these gerbers. And by the way, I changed the name of that PCB gerbers to main gerber, PCB gerbers and button, because I'll go ahead and upload the button gerbers as well. So we can do the PDF. So let's just select these guys and open. Okay. Let's see. Okay, so added BOM and schematic. So now I'll say added BOM export PDF. Okay. And here, see, this is so I can commit them directly. I don't think you'll be able to. So let's go ahead and we'll create a new branch for this, and I might be really just screwing things up, but hey, what the hell, right? So we'll call it Muxall patch 1 is a new, I don't know if I want to call it that. How about the 0.3.1? Okay. All right. So open a pull request. Create a new pull request by comparing changes across two branches if you need to. You can also compare across forks. So it looks like it did a check and it says these branches can be automatically merged. Very nice. All right. So it's just showing the 3 binary files. Okay, let's just create it, see what happens. Oh, we have no continuous integration. Okay, so added BOM and schematics. Muxall wants to merge one commit into 0.3 from 0.3-1. All right. Okay, this branch has no conflicts. I guess this is so if after I review it, then I can make some other comments like blah, blah, or let's make it, let's see, great job. There we go. That's positive. Okay, so confirm merge, yeah. Okay. I guess it didn't add my comment, so all right. Well, maybe we don't need to add a comment. Well, we'll add it anyway. Okay, so we've merged them. Now let's just delete this branch because we definitely don't want to start a new branch. And well, let's see what happened. So code. Let's see, hardware. Oh, okay. Well, they're there. It's still under branch 3. So now for this video, you're going to want, so I need to create another release, I think. And you'll have to bear with me. This is all new for everybody. So, so I want to create a release. Oh, on second thought, before I create this release, I'm going to go ahead and upload the gerbers. Okay, I went ahead and zip the main PCB gerbers. And let's see. I guess I need to do another pull request, don't I? So let's go back to the code, upload files. Okay. There we go. Let's go look at our code. Hardware. Excellent. So, okay. Now there's everything you need. So, you don't want to get in the habit of downloading a branch. So for like this video, which is video number 4, or Muxall Open IoT video number 4, you're going to want to download the tag or a release. And the reason why is because if you're watching this video 6 months from now, branch 03 might have changed dramatically from that point in time. So, or yeah, from when I create this video. So I need to create somewhere around here. Oh, here we go. Releases. I need to create a release. Draft new release. Tag version 3. Okay. So it's going to be Muxall, Open IoT number 4. Okay, so that's the video it's associated with, and I don't know. This tag is associated with Muxall Open IoT number 4 video. Video. Okay. And I guess I could put more information in there, but I don't think we need it. Yep, this is a pre-release, publish release. Okay, number 4. Okay. Very good. So now when you're watching this video and you want to follow along, you want to download tag version 0.3.3. All right. And I'll put that in the video somewhere. I'll have to figure it out when I'm editing it and pop it in there for you. All right. Another thing I'll do as well is I'll put a link to the GitHub repo in the comments under the video. The link. I don't know if I can put a URL in there that'll go directly to tag v0.3.3, but I'll see if I can. Otherwise, it'll just be a link to the repo itself. All right. Okay, so I went ahead and updated the button schematic, and I've also added the Gerber files and zipped them up into button PCB Gerbers version 4. Schematics also version 4. So I'm going to go ahead and create the pull request. So, okay, let's see what happened here. Let's go back to the code. So, hopefully the branch has everything. Let's see. Yep, it does. Good. Let's go. Now we know that this tag hasn't. So, yeah, we'll just go ahead and create a new release. I guess we'll call this... Ooh, I don't know if we can call it the same tag. I wonder what would... Yeah, it's not going to let you do that. So we'll call it... I could call it like 3.3.1. And I don't know. Oops. I don't think we'll do that. Just add a new tag. Okay, so went ahead and added the description in there. Let's see what happened. Oh, this is a pre-release. Publish. Okay. Tags. Releases. Yeah, so now we've got 2 of them that are identical. I'm going to go ahead and edit the name out of this. I'll just call this test. All right. Hopefully that's descriptive enough. Maybe I'll leave 4 in there. Okay, update. Okay, let's go take a look at them. Okay, hopefully that's... that's probably clear as mud, isn't it? All right, well, there you go. Okay, so I think that's about it for this video. If you have any questions or comments, leave them in the comments under the video. If you like this video, give it a thumbs up. That helps. And I will see you next time.